Okay, hello guys. So here we are with the Algebra 2 Chapter 1 Lessons 1 and 3 video. So this will be for your next set of assignments. So we only have a 15-minute time limit with this new software that I'm trying out. So let's get right to it. We're going to talk about relations and functions. Now recently what we just finished doing is we just finished working with what we call equations. But functions, it's a lot of similarities between functions and equations. But let me get you an example of one. So right now, the masks are very popular. You know, but those masks that are protecting you, the ones you're supposed to wear in public right now. So, sorts and different kinds. But let's say that a particular mask, a company is selling a mask for $3 a mask. Okay, so they're selling a $3 a mask, and you're buying them online, and they happen to charge you, let's say, $5 for shipping, regardless of shipping costs right there. So regardless of how many masks you buy, this particular company says, you know what, flat fee, $5. So you don't want to ask for just one mask, but let's say you do, right? So then if you ask for one mask, then you're going to spend $3, let's say, times 1, that's 3, plus 5, that's 8. And this is what you're doing. You're saying 3 times 1 plus 5, and that's equal to 8. But okay, what if you want 2 masks? All right, 3 times 2 plus 5, that's 3 times 2, 6, plus 5, that's 11, and so forth. Well, you don't want to be calculating it for trying to figure out how much it's going to be for 3 masks, 4 masks, 5 masks, 6 masks. So what you start doing is you start writing what we call function notation for this to represent this. You're going to write function notation. So in function notation, typically we use f to represent the name of the function, but it doesn't have to be f. It could be g or h or p. It doesn't matter, but a lot of times we use f because of the word function. So we'll write f parentheses x, which is really read as f of x. So this equation about the mask situation would be f of x is equal to 3 times the number of masks that you buy, that's your input value, plus $5 worth of shipping. Right there, that is your function notation for this situation. Now, this function notation, you can generate a table from there. A table of values where x, your input value, is going to determine your output value, which is going to be f of x, or sometimes we just label it as y. So f of x and y will represent the same thing when we're dealing with tables and graphs. All right, so let's say you order 1 mask. Again, you're saying, what is 1 mask? Well, you substitute 1 into the 3. What you're actually doing is you're actually finding f of 1. So this is your official function notation for that. You're saying, what is the function f with a 1 as my input value? So 1 is my x. So 3 times 1 is 3, plus 5 is 8. All right, so we have that. What is f of 2? Okay, now you put the 2 in the x. That's 6, plus 5 is 11. What is f of 3? And this is the official function notation for a specific value. These are specific function values. At 3, 3 times 3 is 9, plus 5 is 14, and so forth. So this is what it generates on a table. 1 equals a, 3 makes 14, 4 makes 17, and the trend continues. If you buy 5 masks, that's going to be $20 and so forth. All right, so this is your table of values. I'm going to go over several vocabulary terms that are part of Chapter 1, Lessons 1 and 3. So once again, this is function notation. These are function values over there on the right. And then we have the specific word. So the first set on this column, those are called the domain values. Domain values. And the second set is called the range values. They're called range values. So the domain is the first values, and the range is the second values. Another way that they are referred to, or other terms that they're referred to, is the independent variable. So the x is the independent variable, and the range is the dependent variable. And I'll explain why that is the case. See, you choose how many you want to buy. Do you want to buy 3 masks or 5 masks or 8 masks or 10 masks? You're going to decide that. So you get to choose how many you buy. That's independent. Once you decide, you know what, I'm going to buy 5 masks. Okay, once you determine 5, now you put it into this formula and you get a 20. So the 20 depended on you choosing first. Okay, so you determine how many masks you're going to buy first, and that determines how much you're going to pay. Okay, so that is the dependent variable. Independent comes first, dependent comes second. So that you never forget these terminologies, a lot of times I use this example right here. So right here on the side, I was meaning to draw with a different color, but that's what came up. Oh, there it is. All right, so over here I have Dr. Algebra here. He's smiling. So Dr. Algebra, any doctor, by the way, needs to always have an ID. So I'll say Dr. Ophthalmology, or Dr. so-and-so Pediatrics, Dr. so-and-so Cardiologist. Like, a doctor always has to have their ID with them all the time when they're working, right? When they're working. So what I like to use is this example right here. I like to, for you, whenever you're in doubt of these words, put the words D-R-I-D. A doctor will always have to have their ID all the time. So a doctor must wear their ID. Therefore, it's domain, range for doctor, ID, independent, dependent variable. So the X is your domain, the Y is the range, or the F of X, which is the same thing as Y. All right, so these are some of the vocabulary terms that you're going to be exposed to. Again, this is function notation right here. Now, in this particular case, if I make a graph out of it, and I'm not going to make a perfect graph here, but just a quick sketch of it. So if I label 1, 2, 3, 4, 5, and let's say this is not going to be to scale, but let's say 8 is here, let's say 11, 14, 17, and 20 right there. Again, I didn't make this graph to scale, just a quick example here. So my X variables are going to be 1, 2, 3, 4, 5. My Y variables will be 8, 11, 14, 17, 20. Again, there's, of course, other numbers down here, but just because I'm pressed for time here, so at 1, it cost me $8. At 2, it cost me 11. At 3, it cost me 14. At 4, it cost me 17. And at 5, it cost me 20. Okay, so this is discrete data. This is just data that's being generated and plotted here in a graph. Numbers. But let's say we actually graph the entire equation there. F of X equals that. Now, right now, this graph would be going like this, right? It's increasing. By the way, I guess I have to go this way, right? For you guys, because I am facing you. Anyways, so that right there would represent the graph. Now, you're not going to buy 0 masks. In this situation, you wouldn't buy 0 masks because 0 masks would mean that you would still have to pay $5, and I don't think you want to do that, right? So the official domain for this one actually starts from 1 and goes on to infinity. Now, we have to be very specific that it's only, like, you can't buy half a mask and so forth, but I'm not going to confuse you yet for that. We'll confuse you later. No, I'm just kidding. No, I don't want to confuse you now. So what I want to do is simply do a little bit of domain values for this situation. Let's say I'm not looking at the fact that we're not going to cover decimals or fractions in this particular situation. Let's say the graph is connected, and they started from that one value and graphed forever that way. So my domain value would be, or my domain from, and I'm going to put this little bracket. This will be 1, and then I'll put an infinity symbol. This right here is interval notation of my domain. Interval notation. I'm giving you a lot of vocabulary here, but remember, you can always pause, rewind, replay this video as needed. All right, so this is interval notation describing the domain if this graph was connected and started at 1. In other words, if that thing started like that. Now, the way I've drawn it there. Sorry. Okay, the range would be the y values. Remember, the domain is the x values and the range is the y values. So the range values would begin, if you look at my graph over there, would begin at 8. It starts at 8 and it goes into infinity, up forever and ever. So my range would be from 8 to infinity. This is called interval notation. Now, you want to be exposed to all the different things that you're going to be exposed to here. Like, you want to make sure you're aware of all these words. So we've covered domain and range, which is your x and your y. Independent, dependent, also x and y. Input, output, also x and y. Function notation is that f of x is equal to, and then you have some sort of math expression. That's function notation. And let's see. So now we're talking about how to describe the domain using interval notation. But you're also going to have to be exposed to this idea right here. Expressing the domain and range using set builder notation or set notation. So what we're going to do here is we're going to say, little squiggly lines here, I'm writing in blue down there. The domain in set notation or set builder notation, I'm going to write it here, set builder notation, is the following. You're going to say the domain is the x values, and then you put a little bar meaning such that the x values are greater than or equal to 1. And then you close the little squiggly line, meaning that's the end of my set notation. So now for the range values. The range values are the y values such that the y values are greater than or equal to 8, and then you close it up. So we've covered several vocabulary terms here. Domain, range, independent, dependent, input, output, interval notation, set builder notation, and then we have a little doctor there. All right, we're going to move on to more specific examples. All right, so let's say that we have different graphs here. If I have a graph of this right here, this would be like a linear graph right here. Of course, here's my x-axis, here's my y-axis. I could have a graph of something like this right here. This would be what we call a quadratic equation, a quadratic function. Here are my graphs. We're also in this class going to study different ones. Absolute value. Let's go with a cubic. Well, let's go with absolute value, and let's go one like this. We're going to study all of these functions. I'm going to put some numbers here just so we can practice with our domain and range. Let's say this number right here was the number 7. Let's say this number right here was the number 3. The line, well, we won't need to put numbers. This right here would be a function. This right here would be a function. This right here would be. We're going to give you the specific ways to name those functions with equations later, but right now just understand that they are functions, and what I'm going to write is the domain and range of these. So for the first one, meaning that the graph, if you analyze it, no matter if you start from the left to the right, there's something on the graph. If you start over here on this side of the x-axis and you look up or down, oh, there it is, there's part of the graph. If you go here, there's part of the graph. Like the graph is spotted no matter where. As you start from left to right, no matter where you start, you're going to see a point on the graph. Like there's going to be something on the graph. So the domain, the x values, you can put any x value on the left side or any x value on the right side. No matter where you go, there's going to be something on the graph. So the domain is from negative infinity to positive infinity. The range will also be from negative infinity to positive infinity, because if you look at the graph from the bottom up, so when they're asking you to identify the domain and ranges, for the domain you're going to start from the left to the right. For the range you're going to start from the bottom up. All right, for the next one, the domain is also from negative infinity to positive infinity, because the graph, no matter where you look at it, from left to right, if you look up there or down, there's a graph there. For the range, though, if you start from the bottom, because remember the range is the y values, if you start from the bottom here, there's nothing. There's no graph. It does not begin until you reach 3. And then after that, there's a part of the graph everywhere. So my range would be from 3 to infinity.